So welcome to RAAONLINE, and I am Dr. Jay Kumar, working as Associate Professor in the Department of Pharmacology. So today I am just going to take you through the topic on pharmacokinetics, which involves membrane transport as well as absorption. So one of the important chapter in pharmacology is kinetics. Basically the kinetics means it's just a motion. So here we are going to talk about the drugs, how they are going to move inside the body. So it involves actually absorption, distribution, metabolism and excretion. Today we are going to see about the membrane transport first, because that is the foremost important thing. Any drug has to cross different layers, which is a lipid bilayer. So the transport mechanism, how that happens, we have to see. So coming to the learning objectives today, we have to see what is pharmacokinetics and how drugs are biotransported, the different transport mechanisms, and what are the physico-chemical characteristics that influence the biotransportation, and how the drugs are absorbed. So coming to the absorption chapter, then the most important thing is define and describe bioavailability. So bioavailability is nothing but how much of the drug is biologically available at the site of action, and what are the factors that affect the drug absorption. Then finally the concept of first pass metabolism or effect. So today we are going to see all these things. So coming to the pharmacokinetics, as I said, pharmacokinetics, generally they say colloquially what the body does to the drug, or you can say even how the body handles the drug. And the basic components of pharmacokinetics are absorption, distribution, metabolism or biotransformation and excretion. So today we are going to see only the absorption. So coming to what is biotransport, the name itself suggests how the drugs are transported through the biological tissues. So basically it is a movement of a drug from one side of the biological barrier to the other side. So there are three types of drug transport mechanisms. One is passive diffusion, carrier mediated transport, which involves facilitated diffusion, active transport. Then third thing is endocytosis, which involves pinocytosis and phagocytosis. Then finally filtration. So there are four types of transport mechanisms, and the first thing we will see about the passive diffusion. So before that, going on to the passive diffusion, I will just first the physiological thing like cell membrane, because everywhere the cell membrane is present. So the drug has to cross the cell membrane first to go into the cell and to bind some receptor or whatever it is. So the cell membrane is basically a lipid bilayer. If you see this is the one layer, this is the another layer. So two layers are there, lipid bilayer, and these are the protein macromolecules which is embedded in the cell membrane, and they be having a surface where the ligand or the drug can bind to its own site. So basically it is a lipid bilayer. So first, passive diffusion. So passive diffusion is nothing but just movement of the solute from high to lower concentration without any involvement of energy or any carrier protein. Nothing is needed. Just like that, the drug passively diffuse through the cell membrane. So if the drug has to cross the lipid bilayer, then the drug should possess lipid solubility in nature. So there is no carrier protein required, no energy required. Basically only lipid soluble drugs can cross by this process. So this is called the passive diffusion, and it moves from high concentration to the lower concentration. So same thing, as the time moves, if you see that from the extracellular space, it starts moving through the lipid bilayer, and after a period of time the intracellular concentration also increases, and finally it becomes equilibrium. So this is given by basically the Fick's law of diffusion, how the diffusion process happens. So the rate of diffusion of an ion at steady state transmembrane flux varies inversely with the path length and directly with area on concentration gradient. So this is the person Adolf Fick. He is the one who found out this formula for the law of diffusion and named it as Fick's law of diffusion. So if you see that, what he says, the rate of diffusion, the speed of diffusion is basically inversely proportional to the length, that is the path length. For example, if it is a smaller length, the drug passes quickly. If it is a larger length, the diffusion takes time. So that is why it is inversely proportional to the distance. Okay, it travels. but it directly proportional to the area and the concentration. So based on the concentration is more, the rate of diffusion is also going to be more. Similarly, the surface area is more, the rate of diffusion is going to be more. So here given by the formula F equal to C1 minus C2, where C1 is a higher concentration, C2 is a lower concentration, multiplied by the A is the area, that is the diffusion surface area, and PC is the permeability coefficient, which is constant, and divided by the thickness of the membrane. So if you see the thickness of the membrane is more, that means the distance the drug has to travel will be taking time. That is why it is inversely proportional coming in the denominator. Whereas the area and the concentration, it is directly proportional. So this is given by the Fick's law of diffusion.